Woo! Beautiful, beautiful space.
Even if there's a jazz game, all of us choosing to come in here instead of going to for announcements, announcement number one, I'm looking for speakers for 2025. If you have any interesting ideas ranging from data modeling to AI apps, we will take them. We have 2 meetups in 2 different locations. I'll take any of those ideas, so just come talk to me. We can get you scheduled. If you haven't joined for Slack, it is the best way to get in touch with the community. Just go to 4gcloud.tech, click the button on the screen, go to Slack. There's a jobs channel, there's a data engineering channel, there's an AI channel. Random channel, still my favorite. What? There's a new memes channel. There's a memes channel? Oh, that means random's gonna get less funny. I'll have to join that one. What was the site again? ForgeUtah.tech.
Forge.
Yes, Forge Utah is a nonprofit. We run a bunch of meetups and have a Slack community. And we have a mission to put tech back in Tech Week. My last announcement is that Utah Tech Week's at the end of the month. We have the MLOps meetup that week. There will be a Monday. There's an AI mobile app demo. And Clint's building at the college headquarters in Draper. And then we're going to have an AI hackathon Thursday, Friday, Saturday. Good Friday. So that'll be announced tomorrow or the next day. You just bring a team of 1 to 5, build whatever you want, and give yourself a 2-minute demo instead of an 8-minute demo on Saturday. So yeah. I don't have any other announcements. So we'll put time over to Dallin, who's going to speak to us today. I'll let him introduce himself. We keep these meetups pretty chill, so if you have any questions, feel free to reach out and let him know. Let's give him a round of applause before he starts.
Thank you. Yeah, and really quick on the topic of Utah Tech Week, I have a friend. He was the founder of Gatsby JS. He's now working on a new project called Electric SQL. Well, actually, they branded it to Electric. We were thinking of co-hosting an event with him during Utah Tech Week, basically like a hackathon with their sync engine is what they call it. The only thing I really have ever used it for is like local syncing from Postgres. So if that was something that would be interesting to you guys, just feel free to send me like a message on Slack or something, because we're trying to gauge if there is actually interest in doing something techie during Tech Week. Everything else kind of just seems like not as techie. But yeah, I'm Dallin. I'm one of the co-founders of Buster, and yeah, today I'll go through and kind of introduce myself. But I wanted to talk about real-world use cases for AI agents, and then the title in the meetup was in analytics and data engineering, but it just looked terrible all on this page, and so I just cut it short to AI agents. But it's all specifically around analytics, data engineering, and just sharing experience of what we've been doing at Buster. So yes, we'll go through who am I. We'll kind of talk about agents as like it's just a buzzword. And so what is it really, and how does it actually apply? Some really cool use cases that I think, especially in our space, make sense. The demos will actually kind of be like dispersed through everything. I actually, on the way here, decided I would shake things up a bit, and then just at the end, just any questions you have or any discussions that y'all want to talk about, we can go through it. But this is me. I grew up here in Utah, graduated from BYU with my master's in information systems in 2023. I have loved data engineering since even before my master's program. I worked for a few years at Principal Financial Group. They're a large retirement income solutions provider in the Midwest. I helped them. My master's emphasis was actually in cybersecurity. And so when I went and worked for them, I joined their newly created cloud team, where they were migrating millions of assets to the cloud. And I was in charge of helping them provision essentially all their security analytics around their infrastructure, a lot of stuff around network security as well. And so spent a ton of time provisioning infrastructure for security analytics. But yeah, I love living in Utah. I love to bike, hike, love doing everything outdoors. I used to ski a lot more before I started Buster. Now I don't really and I have a baby now. So um, the main things I do now is I hang out with my family and work on Buster. But yeah, Buster is my startup. We essentially have spent the last 2 years doing research on Gen AI and analytics and data engineering applications. We originally started out looking in 2023 at how the OpenAI DaVinci Text 3 model could do text to SQL and how that could apply in production use cases. And at the time, we were like really excited about it, and as everyone was. And in hindsight, I look back at it and it's like there was no way that model could have ever done anything useful um, in that use case. And so today I'm going to talk about some of those learnings and what we do. This is my shameless plug for Buster. Um, we essentially call ourselves an open source AI powered data platform. We essentially try to build AI workers that can do things like data analytics tasks. So your classic text to SQL, like, hey, I want to see our total sales from the last month. If you're non-technical, it generates SQL, brings back visualizations for you, summaries, all of that. And then we also have some data engineering workflows, different things like that. But yeah, let's talk about like what are agents. So I'm sure all of you have heard the word agents. 2024, 2025 is the year of the agents. How many of you have actually like at work um, implemented any sort of agent into your production applications? Like everywhere you go, it's always like this. Yeah, Miriam. I'm about to get there. I'm about to get there. Yeah, yeah. It's because the reason I ask it early before I get into this is there's like a million definitions for what is an agent. And I just like to see the range of where things at. But if I were to define what an agent is, these are essentially like the three main components that I throw on it. Essentially it's intelligent. Now, not intelligent like a human, but intelligent enough to actually reason over an input and give you some sort of output that actually is like reasonable. Different than code, where essentially you're going in and defining all the edge cases, right? You're parsing using regex, if then statements, calculations, whatever it looks like. So intelligent is essentially this piece of, hey, I can actually reason over the data that I'm looking at and go a certain direction with it or give a certain output that wouldn't have been possible just by writing code. Otherwise, you would have needed a human to do it. Independent, if it's truly an agent, it can actually act independently. It doesn't have to. Independence kind of a flexible term, but it's able to essentially run as like a background task and almost, I wouldn't say autonomously, but in a sense that it can operate for an extended period of time, going through what we'll call workflows or through a recursive, architecture of like an autonomous agent. And then where Miriam was hinting at, actions, and that is where that's like the silver bullet on it. Can an agent actually interact with the external world? Is it doing something more than just writing a poem in the voice of Darth Vader or something like that, right? Can it actually interact with APIs, environments? Can it make decisions? That kind of pieces back into the intelligence side. And all of these, to be completely honest, are kind of on a spectrum. But these are like the three core things that I start to look at and think, wow, that looks like an agentive system. One thing I just want to emphasize is not everything has to be an agent. It's a buzzword. Everyone's really excited to throw AI at a lot of things. There's also a lot of machine learning applications that are not LLMs that work really, really well. And so not everything has to be interacting with OpenAI's, models. And I think it's just important to remember that it's not the best use case to always throw every agent on everything or try to make everything autonomous. This is a diagram of this is from Anthropic. This is like from their definition of what an agent is. So you have like your input, LLM. That part we'll kind of look at a bit more. But essentially, this LLM has access to memory. I actually think this is like the most important thing over the next few years for LLMs at this point. It has access to tools. Those are like your API calls. You've probably seen demos of like weather API, and it's like, hey, ChatGPT, what's the weather? And it goes through and does that for you. And then retrieval, which kind of ties into memory a lot of times, in my opinion. But essentially, you can see instead of it being input of write a poem like Darth Vader, and then the output is the Darth Vader poem. That little square in the middle essentially is hinting at some sort of reasoning that's actually reaching out to those systems. Anthropic, I'll give you these resources too. Anthropic has an amazing blog post that they did probably about a month ago that talks about a lot of what I'm talking about today, like what is an agentive system, what are architectures for building these systems, where do those architectures actually, where do they have their pros and their cons? But one important distinction that they have is there's actually a difference between workflows and agents. And part of the reason why I'm running through all this first is just everyone's at a different level of understanding, and it's always helpful to go through it. So workflows. So typically a workflow, it almost always looks something like this. It typically feels like a DAG, or if you're looking at like robotic process automation, Zapier, anything you look at, it typically looks like, you have your node, they're moving a certain direction, there's gates that they pass through and go different directions. This is a workflow, which you could argue is like an agentive structure. The way it gets agentive is these nodes you start to actually have making decisions. So one thing you might do is instead of this gate being like a pass or fail, it might actually be a gate of another LLM evaluating the response or the output of this one and then deciding a certain route to go. The Anthropic article goes through a ton. I actually ripped this image right from them. The Anthropic article goes through a ton of these different workflow architectures. And I figured one thing that might be really helpful is I can show you, Buster's completely open source, so I can show you everything we've written and ever done. But we have like a diagram of how Buster works for our SQL agent that essentially does like text to SQL, visualization, explanation, handles edge cases where it doesn't know what to say, different things like that. And I can actually just pull that up. We can just go through and I can kind of point out some things that we've learned. A few other things about these workflows. You know that you probably should work with a workflow when there are like a predetermined number of steps to accomplish a task. If you actually know, like, hey, from point A to point B, I know that we have to go through step 1, 2, 3, 4, 5, 6. And it's always like, I can always look at it this way. It probably is an efficient workflow. The reason why is workflows tend to be easier to debug because you can catch there was an error here, right? And they're a little bit easier to architect, just in the sense that I'm going one direction to the other. So workflows is one. We'll jump into agents in a second. I was going to hop over and show you guys Buster, but up to this point, are there any questions for me? Anything that I glazed over? I like spend all my time thinking about this and going through this. And so I know that sometimes I might ramble about something that like everyone's like, you make no sense, dude. Any questions or anything like that? Sweet. Cool. You can still see my screen. Oh, yes. One complaint about it's the O1 model. Well, yeah, well, so it's a well would achieve HDI. You know, they spent how much compute and energy on cheap to the higher person. Yeah, that's cheap. Yeah, that's a really good point. Yeah, I mean, it totally depends on what you're actually building, on whether it's worth it to actually try and automate it or not. A good example could actually be like if you look at a SQL analyst, right? Um, Theoretically, like an AI SQL analyst can scale infinitely, as far as we have compute, right? Whereas like a human can't actually scale infinitely, but a human data analyst ends up being like a fixed cost, more or less, right? You're paying on their salary and everything. And so there's definitely edge cases where even some implementations of AI tooling that you put in to maybe try and replace certain processes that humans are doing um, could end up costing you more than just paying a human to do it. Now the trade-offs are: do you want like infinite scalability for this specific task, or is that not the goal, right? And so it's super interesting as far as like testing for costs in situations like these, there are some awesome tools. I can actually, let me see. Am I sharing just the window or am I sharing my whole screen? Let me share my whole screen. And if y'all are okay with me going on tangents like this, we can totally do it. Okay, this is Buster. I was going to try and give you guys a demo. I'll show you later if that works out. Um, there's some awesome tools for quickly prototyping and building essentially like workflows or even agents that you're interested in building. This is not something you would use to actually deploy an AI agent into production, but it gives you like great features for, let me see if they have some good images. It gives you great features for essentially evaluating like, here's an input, here's an output. They do a spreadsheet approach, which sometimes is nice. Other times spreadsheet approach doesn't always make sense, but this company's called Athena AI. They're a new company in the AI eval space. They allow you to essentially build out these large spreadsheets, and between each cell, you can reference each other and essentially try to build your DAG, right, of like a workflow. And then you can actually run evaluations over the top. But the thing that I really like about them is if you go into that little metrics tab, let's see if they have a picture of that. I would show you guys, but our account actually has like customer data in it, and so I can't show that. But in their metrics page, they'll actually show you the average latency, the average cost. And so it's really, really helpful for benchmarking. You do this as like your prototyping space, and then you can actually use it as like evals later for after you've deployed to production. But it's actually relatively easy to try and go through, estimate, okay, what do our costs look like? And then there are actually architectural decisions you can make to reduce your costs. And we can talk more about that. I can even hop over and kind of point out different architectures on the Anthropic stuff. This one's called Athena. Another one that I really like is Brain Trust. They do the same thing. They have really good companies that they work with, but essentially, yeah, you're able to come through. You can see all this different logging information. They track costs and everything like that for you. And so I'm a big believer that before you push any AI feature, just like software, you're just going to do a ton of testing, proof of concepts, really understand your numbers. The other thing that starts to be interesting is not all AI calls are created equal. A good example of us is when we are trying to generate SQL, we pull in whatever tables are necessary to answer a user question, right? And so sometimes that might just be one database table or warehouse table. And so, you see like 200 tokens of context that ends up being like, whatever it ends up being like a half a cent or whatever. But then other requests might actually need more tables. And so then all of a sudden you might have a huge table that comes in, and there are things that you can do to like reduce those costs. But oftentimes memory, as they call it, is dynamic. It's whatever gets the job done. And so you kind of have to benchmark like what is the average cost. I think what I like about Athena is they actually have like your they give you like a distribution of your costs. And so they're like, yeah, 95% of your requests end up being this type of cost and things like that. It's really cool. So I'm a big fan. But did that kind of answer your question? Is that like a good area to kind of go through? Yeah, and another bet that you see a lot of people making. This is cool. I'll show you guys this in a second. Um, that was just in ChatGPT. Another bet that a lot of people are making, which I talked to a guy in energy the other day, and I have questions around energy and AI now. But a lot of people are betting on the cost of compute dropping for these large language models. And so if you look at when we started with the Da Vinci model, which was really low power, not very sophisticated actually, and you compare it to the O1 model today, we were paying more for that model than the O1 model is even costing. And so that's a bet that people are making. It may pan out, it may not. And so the main idea that people are looking at is, yeah, can we actually see the cost of compute go down? Yeah, it depends. If you look at, for example, the HR space, you'll see a lot of AI powered customer support companies working right now. Intercom, Zendesk AI, that's like their new product they've launched. Those customer support chats can often be dollars for them to actually have like customers using. But there ends up being like the game of like, well, if we're paying $2 for this AI chat versus paying a human, I don't know, $5, does it actually pan out? This support chat also scales infinitely. And so we're actually willing to pay in order to have smaller support times, pay for that commodity. And so it totally depends on the use case. If you look at like something like Buster, if we actually, I'll show you like this chat. This is a terrible chat. I was messing with the visualization stuff. We'll hop into this one. I also messed with there's no data from the last 3 months. And this is just a big table. Either way, I'll walk through this with you. Oh, this was me showing someone that you can actually chat with Buster in Spanish, and it responds in English, but it was a customer down in Mexico. So this request that you're seeing right here, where Buster essentially generated this, reached out to the database, fetched this entire table of data. This is like a really messy table. It was a bad request on my part from the get-go. Simple SQL query. And then you peek at all the thoughts that Buster went through. Essentially, before it actually wrote the code, the LLM generated a thought process and a plan of how it was going to actually fetch the data. So you can see here, it's like, yeah, I'm going to use the call center logs data set. I'm trying to understand the request a bit more, maybe rephrase it how I can. Identify the relevant columns, filters, data hygiene, the format that I want to output. Right here, it's like, since the user didn't specify, I'm going to do this. So when you look at all of what we've done here, this totally varies in our case, but a single request like this could cost us like 5 cents. On the low end, if we actually have a router that decides what power of model to use. The models have different like performance levels. If we identify something as a simple query, we will actually use cheaper models to actually service that query. Just because you don't need like the most powerful model in the world to generate an 8-line SQL query that's a select all, right? So yeah, I can't give you like an exact answer. I guess I was trying to give you, different use cases and what those costs kind of look like. But it totally depends on the use case. It's like the same with any software, right? If you're paying for a managed service versus hosting something yourself, you might see different costs. There's just different trade-offs there. So yeah, you guys have kind of seen Buster. You can see that there's like a few things happening here. Like I asked to see all the calls. A simple SQL query was generated. I then tried to follow up on another thing. Yeah, I was just wanting to see another thing. Turns out there's actually 2 data sets that could answer my question. So Buster's like, hey, I actually have 2 data sets that could answer. Which one do you want? There's kind of an engagement there that one could argue for better or for worse is a good or bad thing. The reason I show you that is I'll get to you in just 2 seconds, is because we are going to hop back over here. And this is our workflow that we have with Buster. And we'll start walking through that. But what was your question?
This is like, you were giving that example of sort of complex prompted response to, I guess, whatever the original question was. What's the question is like, I heard you talking about how you can evaluate a prompt or a question
Yeah.
level of complexity, and so you can, I guess, determine whether or not extremely structured and complex response is warranted or not. I have problems with that in my sort of personal life, using LLM. And I'm wondering how or what your thoughts are on that, because some of the newer, like say, public models like GPT, like sometimes overthink things for me.
Oh yeah, 100%.
So I can just imagine myself trying to implement something with this model, saying like, wow, I really want to wait for it to go 10,000 tokens deep into something.
Yeah.
To come up with one false assumption, shoot the whole thing. But I go back to the simpler model all the time.
Yeah.
And I do the meta prompting myself.
Mm-hmm.
I guess it goes back to like how much of that is actually, based on your experience, is built into the actual model itself to respond that way, or is it there's machinery around engineering, that's sort of like prompt engineering being done for you so-called model?
Yeah, so we actually do, and you call it the meta prompting. We actually do that with the thought here. We tell it the steps that it should think through to try and answer the question. It's essentially trying to highlight like certain best practices. You'll notice that there's like this relevant terms that pops in. This like is a term that has to do with call agents. It says the top agent is whoever answered the least amount of calls. That was like a joke that I was making with it. Um, there's like certain things where if Buster or like the LM in this case was trying to think through what does top agent mean, we're surfacing certain context and having it specifically say, hey, you need to think about this context if it's there, right? So in this case, we identified there was a data set. We identified that there was something related to calls. And so we essentially just dropped in, hey, you might want to peek at this top agent. And so it's like, okay, I think this is kind of relevant and it's thinking about it. And then you also see there's actually a piece here that we hide because it it doesn't always make sense, and I'll show you like in our workflow in a second. But in this thought, there's actually a final like summary of like everything. Um, and that actually will cover a lot of things around what type of visualization it thinks it should actually build, because that actually affects the sequel. Like if you're gonna, show like a line chart, you actually have to have like the right data that fits on a line chart. And so it's actually trying to also think through how can I make this digestible? And so here you notice that the output format, it's like, I'm just gonna give them a table report because realistically the question was show me everything. It's in Spanish, but and my face is covering most of it. Um, but yes, the newer reasoning models are known that they can, like a bug in them is they overthink and they essentially can compound on their errors and continue to go down like this huge path of like 20,000 tokens. It's going to cost you like $5 and then it ends up getting to nothing. And that's kind of a risk that you do run. I kind of joke with people that sometimes that happens with humans. It happens with me, definitely. I'll like spin my wheels on a problem for like an hour and then I'll like go get some food and come back and I'm like, what was I thinking? Like, this is the answer, right? And so it's all like a balance of when when does it actually have to matter or not, right? Um, but it definitely is extremely frustrating if, especially in this case, you're like, I just want to see everything and it can't give you everything, right? Any other questions?
But I can answer. It's more of a thought process.
Yeah, yeah. So yes, so yes, we love FigJam. That's where we model everything. So we have a SQL chat. You can see they're like all these tiny little nodes. They're a little blurry. I'll zoom in on them. But essentially, there are a lot of things that we do to make sure that you can actually reliably get an answer to your questions when you submit a request to Buster. Our goal is to make it so that data teams aren't like swamped with like a million ad hoc requests. And honestly, most user requests are simple requests that are tweaks in like 2 lines of SQL queries. It's usually for filters or something like that that they wouldn't be able to do on their own. Talking about non-technical users. And so our goal is to essentially free up data teams so that they're not just swamped with a million, simple ad hoc requests, can actually do the work that they thought they were going to be doing when they finish school. So an input comes in. Essentially, this input is a request. It could be literally anything. It could be show me my total sales. It could be what can I even ask about? It can be who is your daddy? It could be anything. And essentially to give like a good user experience, you have to be able to catch it all. And that's like an interesting thing that we deal with. If someone says who's your daddy and Buster doesn't respond the right way, they're like, it doesn't even work. And you're like, well, you asked a dumb question. And it surprises me all the time. So the way that our architecture is set up is we have what's called an orchestrator. So Buster essentially has 2 main tasks that it's trying to do. It's trying to generate SQL and then visualize that data for you. And so when you ask a question, you could ask something like, show me my total sales. It's just a really vague request that doesn't have like a particular visualization assigned to it. So realistically, it could be sales over time. You said total sales, so you're probably going to get a single metric, right, of your total sales. Now, you could say, show me my total sales on a red line chart. Now it's interesting because you said total sales, but you also said red line chart. And so the single metric isn't going to fit on a line chart. it actually at the SQL level has to understand that it has to be broken up by something, and usually it ends up being time. So what we do at this orchestrator level is we actually have Buster take in requests. Buster knows requests that it can make from that request. So the output of Buster is actually a series of requests. And you'll see, like, we call these classifications here. But essentially what happens is Buster is saying, hey, I got a SQL request and I got a visualization request in the case of show me my total sales on a red line chart. Now, this is dynamic because it could also just be, hey, I just got a SQL request. They just want me to filter something, but they don't want to change the visualization, right? And this is where it starts to get interesting on follow-ups. Or it could be they just want me to make the chart blue. There's like these dynamic tasks that could happen at any time, but they do go down a predetermined route, right? If you want a visualization change, we know how to change your visualization. If you want SQL to change, we know how you want to change. Now, there are some edge cases you'll see as we kind of walk through it. But an orchestrator is like a really effective architecture for building systems where you can take in an input and you have these workflows that you know about, but you don't know which workflows will be used when. And so the orchestrator does in my opinion, it can do a really good job of deciding when to generate SQL, when to modify the visualizations, when to say, hey, I can't do that, when to explain what else a user can ask about. Yeah. Yeah.
Oh, user just asked this question.
Yeah.
I know that I interpret this way, so these are the same steps.
Yeah, so this is session based. Every time a message comes in, so the first message, there's no history. So you can imagine from this point on, it's like point blank. It just goes through. But when a user follows up, which happens all the time because most of the time you don't find the data you're looking for the first time you ask for it, you then need to follow up. And the LLM needs to know, what were you asking before, right? If you said something like filter this to the last 3 months and it didn't know what the query was, it didn't know what it was working with or anything like that, it's like, well, like, what am I supposed to do at this point? Like, what am I filtering, right? And so essentially underneath all of this, we probably could have diagrammed this better, but underneath all of this, there is like a memory layer of like essentially your message history and all the actions that were taken at certain levels. So at this orchestrator, if I said show me my total sales, that is just like simply a SQL request if it's possible. So you'll see that the orchestrator decided, hey, I'm going to generate SQL, right? And then there will be some other outputs that go in there that we can show there. But then underneath it, when I follow up, which is essentially that new message, right? I may say something like make it on a line chart. And so the orchestrator may evaluate, okay, I need to redo the SQL because the current SQL isn't going to get me data for a line chart. And I need to actually put it on a line chart, like consciously do it. And so there's essentially this long message history that kind of goes through there. And it is a whole like game of what you feed and when as like history. If you feed in like just too much and you're just like shotgunning everything, you can see performance drastically dip on like task performance, especially with cheaper models. And so it is a game of like, well, what does the LLM actually need to know in this situation to be able to accomplish the task, and like really trying to skim it down. And that saves you a ton of money. Yeah, a lot of the LLM providers provide like through their APIs and everything, they provide like the ability for you to input the chat history. And so you're essentially concatenating those messages. Yeah. Yeah, we at every step of this, we manipulate the outputs and we pick out like what happened and we change those based on the task that we're trying to accomplish. Yeah, that may not be a great answer. All of our code is open source though, so you totally can go in and hop and check it out if you can read. If you can read my ugly code, you got it. I'm gonna just speed up a little bit more through this and try to get to some like other use cases that isn't what I work in. But yeah, you'll notice here that essentially we have this conditional node that we peek at. Hey, was modify visualization, was that picked out with a request? Was there an explain SQL? Sometimes people say like, explain how you got this for me. And they just want like a more clear explanation of how the data was derived. We have like these other two that kind of just are catch-alls of like explain something general, or I can't do what you asked me to. That's when someone's like, put a regression line on this. You're like, we could, but we won't. in that case, or they request a chart that like isn't actually compatible with what we support, like a Sankey chart. People ask for Sankey charts, and it surprises me. I didn't know Sankey charts were as used in business as they were. But then you'll notice like Buster starts to just kind of go through like this DAG of like, okay, well, I was asked to generate SQL, and those are kind of blurry, so I'll zoom in. Okay, I need to essentially pick out the data sets that are relevant. So we don't want to feed in your entire schema of 1,000 DBT models. We're trying to actually pick the most relevant ones. You'll notice that we even like benchmark it in here. We're like, okay, it takes us 1.95 seconds on average to pick the data sets. You parse the data sets, we bring these in. There's other things that we go through of like, well, is there one data set selected or are there multiple? And then that just takes us on this whole other thing where you can see there's a little recursive thing that happens here. Oh, that's not completely recursive. It kind of bounces back in here. We do SQL thought, SQL gen, and then you can kind of see that it flows all the way through. One thing I want to highlight from what we do, there is a recursive step that you see here. Did the SQL run successfully? This is actually not as big of a problem as it was when we were working on this a year ago, because the models are like way better now. But sometimes there were just syntactic errors where the models couldn't understand the syntax that they were supposed to be writing in. So they would like be writing Postgres SQL statements in BigQuery and Databricks, which is, you know, Spark SQL. Like it's essentially just mixing up dialects. And so we would run into this issue where for a BigQuery, like we tell it and everything, like you're querying a BigQuery instance, and it just like the models wouldn't do it. And so we would go into this whole thing where we feed the error in, and we essentially are trying to re-instruct how the LLM should rebuild its query to answer the question. And this is like another common thing that you'll see. Essentially this LLM and evaluator architecture, where if you know what the specific criteria is for an LLM to pass its task, it's really, really effective to actually have it recursively evaluate itself. LLMs are like terrible at understanding when they make mistakes, like in real time, but when they like reflect on themselves, they like always catch their errors. And it's like funny because you're like, well, I expect you to do it right the first time, but that's like how humans are too. And so it's like funny. I spend way too much time in this space, and I'm too empathetic with the large language models. But so yeah, the task here is like really clear. It's did the SQL run or not? And you don't even need an LLM to like necessarily tell it why it didn't run, because luckily the warehouses and databases give pretty good errors back. So that is one thing. And then the last thing I'll mention that actually is like, so common problems that people run into when working with LLMs is latency and cost. There are a few things you can do to reduce cost and reduce latency. Reducing latency, we have like all of these different chart combinations that you could actually plot your data on. We like to run all of them at the same time, even if the data doesn't completely match, because we like to be able to enable you to just click through charts and just see it change. Even if the chart that you're clicking on isn't the right one, we just want you to be able to have like a zero latency experience clicking through charts. And so we actually fire off in parallel, essentially 1, 2, 3, 4, 5, 6, 7, 8 LLM calls that all run, they all take about a second, and they come back instead of doing like, basically what we were doing before is we were like going through steps, and it was just taking way too long. And we realized that there are certain calls that are not dependent on others. So for me to actually build a pie chart where I'm essentially assigning axes, like everything you need to know to build the most minimum like pie chart, it's really only like 3 fields. It's just like axes on a pie chart, which aren't even like axes. And that doesn't actually need to know anything about the styling. If a user says something like, hey, I want it to be purple, it does not matter what the chart is. Well, there's like edge cases when we can get into that, but like really for the most part, it doesn't matter if it's a pie chart, doesn't matter if it's a line chart, doesn't matter if it's a bar chart. We know that it needs to be purple, right? Or if users are asking for things like round the bar charts, and they're like, we're gonna round a bar chart here, but we don't actually need to know if you're looking at a bar chart. We can just still round the bar chart, because when you click to the bar chart, it'll then be rounded. So there are like things that you can think through when you're architecting these systems of what needs to be known for each of these tasks to be accomplished and what can actually be separated out. And what you'll notice is sometimes this ends up turning your context that you're feeding in into like little chunks. And then you can kind of pick what things you want to run at different times. It just ends up saving you a ton of money instead of like running one big prompt for all of this, right? Like in this case, for like the bar chart, there's probably like 20 fields that could be generated. But we actually come in here and say, hey, do we need to generate any styling stuff? And if we say no, then the bar chart only ends up being like 4 fields. And so it saves us just some money and latency in that perspective. So that was kind of a ramble about like things that we do and kind of what our architecture looks like. Like I said, we're open source. You can go peek at the code. And I'm happy to geek out about this all day. I'm going to hop back over to this and kind of walk through what actually we think the next version of Buster is going to look like. And then just some other use cases that aren't my business. Any other questions before I move on to that? That was that. Agents. That's a workflow. Yeah, yeah. Yeah, it looks really close to like, it looks really similar to like robotic process automation, right? Like when you actually look at software like UI, you're like, oh, there's like a little thing that comes through and just like baked out.
No, but you talked about like the version.
Yeah, I'm about to mention that right now.
That's not that.
Yeah, I mean, that basically is just like a workflow that's going step by step by step by step by step. Okay. So yeah, autonomous agents. So what you saw that I just showed you was our stuff. It just like went beginning to end, and then it was just like, you know, there were basically all these predetermined steps. Now, autonomous agents is essentially this idea of, hey, there's an input that comes in, a human, and the reason why they actually say human instead of input is because there might be, you know, some interfacing where you're cutting the agent off, injecting information, whatever that looks like. But essentially, it is like these LLM calls that are essentially interacting with an environment through actions. Those can be API calls, those can be functions, those can be, most of the time they're just API calls. And then as that action is being taken, the environment is giving feedback to the LLM for it to accomplish its task, basically until it reaches a point that it's like, I've done what I need to do, and the agent says, I am done. And so then the agent exits itself. Now this is really interesting because the problems with this is they're more latent, because the LLM is like going through these recursive thoughts of like, what do I do now? What do I do next? And sometimes you can just do the thinking for the LLM and just tell it what it needs to do next or skip that whole piece. And it ends up being more expensive because of that reason, because it has to actually keep the context of what it's been thinking through and what it's been doing. And it's a little harder to orchestrate that in. And then there's the potential for compounding errors, essentially where it starts to go into like this doom loop of thoughts and it's just not able to break out. And that's where you'll typically set like recursion limits, but that sucks. You just spent like, you know, $5 on this agent just going in circles and then ultimately not accomplishing the task that you want. The reason why this is a cool architecture is because it works well for open-ended problems where it's difficult or impossible to determine the number of steps or tasks. So Buster, we're actually going to be transitioning what you just saw, our architecture that's a workflow, to this. And the reason why we're accepting all the risk on doing this is because as we've been implementing our product with customers, we learned that most non-technical users do not know exactly what they're looking for. Like they ask questions like, tell me how my sales are going in the Northwest region. It's a very open-ended question, right? Now it's cool that they can say, what were my sales in the Northwest region last month? But when they say, tell me about it, it's like, what does that actually mean? Like I could give you a lot of different metrics. As we interface with data teams, they're often like, yeah, well, most of my time is spent trying to figure out what they're actually asking for, not, you know, not giving them what they're asking for. And so we're actually going to be transitioning. We're like in the middle of POCs with this internally and pushing it out and everything, essentially where you can actually approach Buster and say, hey, I'm the manager of the sales team. I really want to know like how things are going in the Northwest region. And essentially Buster starts to go through this recursive piece of, well, let me think about the metrics that I have access to. Goes through, does that. Cool, I have access to these metrics. What do I think is relevant? Cool, I have that. Now I can generate the SQL for it, which is kind of like, you know, the final piece that we've spent so much time on. Goes through that. What visualizations? That's kind of part of the SQL piece. And then essentially, we hope, we haven't completely finished it yet, that it reaches a point where it says, yeah, I think this is a good report. I'm going to send it your way, right? And so that's something that we're working on. Yes.
So
Exactly.
say they'll be interested in this number and this salesperson or whatever that means.
Yeah, yeah. So part of this push that we're doing is actually, we call it a memory push as well, where every time a user interacts with the system, we basically run it through some post-processing where the LLM decides, hey, is this a new memory that I should keep track of? That memory being this person's really interested in Northwest sales, right? Or their KPIs are this, or different things like that. Trying to get to know the user better to be able to hopefully give them, more personalized and relevant insights when they say, tell me how things are going, right?
About not just generating reports so I can look at something, talking about competition, about where's the actual problem and where, how can I improve things? How can I, what are the knobs and buttons and checkbox hit the goals that I would have?
Yeah, yeah, more or less. The tricky thing that we try to stay away from is the LMs still just don't have a lot of context about your business in the sense of like how things actually improve, right? Like it may look at a lot of numbers, and especially from a SQL perspective, right, where you're not doing a lot of statistical analysis. The LM might actually be looking at things and saying, "Hey, it looks like if you," and we actually tried this before. It's like you ask it like, how can I increase my sales? And like strictly looking at the numbers, it's like, well, if you want to increase your sales, just get more customers, right? And it's like, so that's like where you run into like an interesting situation. So we actually try to kind of lean out of like, a lot of people would love for us to tell them how to run their business, but we try to lean out of like giving you recommendations as far as like actions, but definitely along the side of like, hey, I noticed that these are metrics that I think would be important to you, right? But yeah, you're kind of hitting it on the head where it's like more of a conversation and like an assistant instead of like me just doing these one-off ad hoc requests, right? Yeah.
What the limitation, finding predictive analytics, possibly ask it, am I going to hit my,
Yeah.
you could say, hey, my goal is this, by this date, what's the likelihood of hitting?
Yeah. One of the things we do right now is in that orchestrator, we've actually defined like what Buster can do explicitly. So if you actually even say that right now in Buster, Buster will go and fetch SQL that's relevant to the question you asked, but then we'll actually respond at the end and be like, while I could get you this, I can't tell you how to do X, Y, Z. And we do that through like an explicit allow. It's easier to define what you can do than what you can't do. And we say anything that doesn't fall in what you can do is just a can't do. Yeah, any other questions? Yeah, to run the LLMs on your local device, there's a cool software called Olama. They allow you to run LLMs locally. I actually don't remember my computer setup, to be honest. I don't actually run LLMs locally here. Yeah, so like I have a 36 gigs on my computer, and I can run, certain LLMs like really smoothly. But for these larger, like more powerful LLMs, it's going to run really slow on my computer and hog up like all the resources. But all the calls that you're making to the large language models, most people I know, they're doing it up to the cloud with these model providers. And that can be with the model provider directly, like OpenAI, or it can be through AWS or Microsoft Azure in your own cloud, essentially using like this managed service that they provide, just so that you can like keep things in your own cloud. But almost everyone I know working in the space typically runs the LLMs in the cloud. So they'll usually have like a dev key that they use and test locally, basically pinging up to those clouds. It's really expensive. I think the model providers, I mean, if you look at their financials, they're like losing money. And so there is a big bet on compute getting cheaper. And so it's interesting, like looking at the whole space and that bet. We'll see how it goes. But I was talking to a guy about energy the other day, and he was like, "Yeah, I have like I think he said it was Meta was talking to him about building like a data center. And he's like, there's no way they're ever going to get it done. And I was like, I kind of need him to get it done. And so, anyways, yeah. Did that kind of answer your question? Okay. Um, so yeah, some quick little tips for like building agents. It's really easy to like immediately be like, I want this cool recursive agent that I can chat with and kind of have like, this conversation with. Um, Recommendations like keep it simple. There are actually a ton of tasks where just like kind of going through a nice little pipeline is like sufficient. Um, that combine these patterns doesn't actually make as much sense because I tweaked my slides and I showed you like all the patterns. I'll give you the resources for that after. But like those different patterns of, thinking through where it evaluates itself, having an orchestrator, running things concurrently, you can combine all those even with like an autonomous self. And then this is like the most important thing that everyone needs to always think about. When you do have it interacting with external systems, you just have to be very conscious that it is basically as if I would say like a dumb human is interacting with your systems. Make sure that the environments you run agents in are safe. One thing we do for that is we have we have a SQL parser that we use, and we parse every single query down to the functions that it's using, what columns it's trying to filter on. We try to do everything we can to keep an LLM from ever being able to do anything malicious or wrong or anything like that. And so we're like doing it on the SQL, basically the abstract syntax tree level. We're like evaluating everything. So there is oftentimes work that you probably have to do around access controls just to make sure that it works that way. Here's some really good resources. I'll also just like throw this into the Slack and you guys can, yeah, I'll just share them in there. Here's some really good resources that I think can help you learn more. Just some caveats. So the Anthropic Agents blog post, I think, is the best explanation of agents that exists out there right now. LangChain and LangGraph are good open source libraries for kind of formulating concepts about how agents work and stuff like that, but I would never recommend using them in production. That's just my personal opinion, but I use them.
The only one that.
Yeah, I'm like, I know a lot of other people share my
Definitely
opinion.
not the-
I'm like, I recommend them for like toying around and actually figuring out how does it work and what are patterns I can do and what can I actually prototype. Do not ever deploy this in production. Crew AI, I've never tried to deploy in production, but people say it's great for testing and doing so. I would recommend the kind of the same thing here. AutoGen is another library from Microsoft that gets a lot of attention around agents. Llama Index, once again, I wouldn't deploy it in production, but I can test some really, really interesting patterns and concepts around context with external systems. So like, going through your Google Drive and have you parse that information, different things like that. And then if you are more of the, if you like to see it visually, there's an app that I found that I like called LangFlow. It allows you to kind of build these DAGs visually. And so instead of it all being code-based, you can kind of like piece things together. It's really easy to prototype, mess with. So yeah. And then what time am I at? I'm at 7. All right. I'm gonna tie things up. Yes, I didn't get to as many use cases as I wanted. Yeah, so my hot take on production level agents or workflows is we spent 2 years trying to apply this in tons of different spaces in data, mainly around analytics. It did not feel like the agents could accomplish tasks as reliably as we needed them to until basically the last 4 to 6 months. That's with the release of the GPT-4o model, the Cloud Sonnet 3.5, and then recently with the O1 series model from OpenAI. They are like phenomenal. They are extremely impressive how good they can do and accomplish the tasks. And it has felt like things shifted from I'm giving the model everything it needs and it's just doing a terrible job to I'm actually giving the model everything it needs and it's doing it and I actually need to give it more so it can do more. And so it feels like in the last 4 to 6 months, it has completely changed. And it's only going to get better, cheaper, faster. At least the cheaper part, is still a bet. So yeah, some quick use cases, AI data analyst, that's us, selfish plug again, ad hoc reports, report building, visualization building. You can see advanced analysis is like another use case. The OpenAI, like ChatGPT chat has it's, they called it open interpreter or the interpreter chat first. Now it's called advanced analysis. You can like plug in CSVs and do like statistical analysis. You could argue you could do the same thing if you start with a SQL query, pull in a data set. You can run, all types of stuff over in like in a Python environment, like a sandbox environment. Data modeling, this is an area we're really excited about because there's a lot of data we can use to improve data modeling within organizations based on how analytics are being used. This is a company called AI. They essentially look at your Looker and Tableau, and they make recommendations to you on how you can actually improve your data models and turn it into like a unified shared model. Because what happens oftentimes is you end up having metrics scattered all over different dashboards. They essentially are trying to scan your business logic, put into a unified model for you. So this is a screenshot I took from their docs. It's essentially making a recommendation about moving this specific metric from like this product KPIs dashboard into their DBT model called inventory items. I think it's cool. We'll probably start doing something like this. We don't do it super well right now, but it's really exciting. Data mapping, cleaning, and validation. If you are ingesting data from a lot of different sources, you have your normalized format. It can happen sometimes that like, you know, you're writing like a million different like regex expressions trying to figure out how to get the data like in. The LLMs can do like a decent job at actually parsing information for you. You do run the risk though that like these are not deterministic systems, but if you run your tests and you're like, it works as often as I'm confident, then I think it's great. You can see here they kind of have like this. This is an ETL process. This is from gather.ai. You can see that there's like the system message of like names, comma separated list of names used, and they kind of give like these essentially recommendations for what the LLM should do here. For data checks around like qualitative things, that can be really effective as well. Where it's really difficult to actually validate something with code, you can have an LLM look at it and try to give you its best opinion. And once again, these are not deterministic systems, but if you test them and you're like, it works how I expect it to, and I'm okay with the risk there, then it works pretty well. I actually couldn't find a company that did this really well, so there is no thing here, but documentation, LLMs are great at documentation. It's just text. They're just writing text for you, right? Trying to explain like what's going on. Business logic documentation is like an interesting thing. We have a customer. So part of our product is we have like those terms, like top agent you saw. We have a customer. Their executive team says, show me hamburgered customers all the time. And that means it's a certain type of churn that happens where like a customer, they came in, they churned, they came back, and that's like that's what the pattern is for that. And so we inputted that directly into Buster, the data team did. But there's a situation where someone may say, show me my top customer. Top customer could mean a million different things to everyone. And essentially they're like, well, top customer means this. You can document that for future requests, right? And so there's some things there. I love the idea of data enrichment and augmentation. This is from Clay. They're like an outreach tool. They have their research product. I think this is like one of the coolest things ever. You can actually grab like, you know, a record, which this is like that Masonite company up top. And then you can actually, essentially with this AI web scraper or researcher, you can go in and say like, yeah, find the names of any of the founders of this company. And then it essentially is an agent that goes through like this recursive research process, and its only goal is to fill that cell with what you're looking for. And I've seen Clay work really well. I've also seen it work really bad. But I get really excited about like looking at it from like a how do you deliver value to your business as like a data team. There's some really cool things that you can do either for your customers or for other departments within your company where you can actually enrich data. I get really excited about the idea of that. Now it can be expensive. And so you just, once again, it's all deterministic. You just have to test it and accept, you know, the pros and the cons. And then this is a really interesting one. And it gets into what we will start doing at Buster. One of the biggest problems we run into is, yeah, people don't know exactly what they're looking for. It's oftentimes, how are things going? What do things look like? The O1 models specifically are really, really, really good at trying to reason over the data available and come up with what it thinks is best for you and your role. I would question if sometimes it's better than just what most people can do. This was me. This is like dead simple. I just pasted my metrics schema in here. So that was just like our gold level tables, right, for analytics. And then I basically said, I'm the CEO of this company. I need to know how the health of my company is from the last 2 quarters. And then it essentially went through this thought process for 4 seconds. And I asked it to do it in Markdown so I could like easily skim it. But you can see that it basically like, there were like 8 more of these. And you'll notice like, now maybe that's too much info, but you'll notice that like, it's like, yeah, the metric you should find is a count of active users versus the total users across time. And it's like, oh, that's actually like that could be a good insight. And so I think it helps with discoverability, especially for non-technical users who may not understand what data they even have access to. especially if you expose, 50 tables to them or whatever it looks like. It just starts to become a problem from a discoverability perspective. So I kind of rushed through all of that. No need to do demos. But yeah, that was basically it. Am I like overtime? Am I on time? Okay. Okay.
I mean, it's kind of Ayla said, I want to go home.
I see. So yeah, I apologize. I have a habit of rambling on things, and I sped through that last part. Any other questions for me or anything that y'all want to talk about?
When he's a buster, I think maybe in terms of like, it only applies to generating SQL, or could it, let's say, you can give them a list of APIs where you can get the information from other websites. For example, let's say a small business wants to know information from their Google Ads and their Shopify. So can it also do like, okay, you need to go to this API doing this for like that?
Yeah, there's a couple of ways you could architect it. One is you could say, hey, here are the Google Ads APIs, and say when you need information about XYZ, you need to go grab that data. And then once that data actually comes in, then you have to do some processing on it to actually get it into whatever format, for deliverability. Or the other side of it is you just ETL that Google Ads data into a warehouse ahead of time, and then you unify that into like the other analytics stuff. And so, yeah, there's like a couple of approaches, but yeah, with these tools, you can specify at any time, like, hey, here's an API that you can call out to, and you call out to it at this moment when you need this type of data or whatever it is. And so then it'll return you a response where it says, hey, I want to hit this API with these parameters. And then you're able to actually do the API call. You bring back the data, feed it back into the LLM. So, yeah. Any other questions?
Summarize data. I assume that's a kind of very.
It is so critical. Yeah, we spend a ton of time. Part of our business is we spend a ton of time consulting. So we go into companies and we essentially say, hey, show us what you got. We go through like, sometimes they have nothing from an analytics perspective. And so right now we spend a ton of time helping them get like their data foundation set up, right? A common problem we run into is like, we have a company like classic data swamp problem where there's like, I think there were like 1,200 DBT models. And they were essentially like, hey, can we expose these models to our users, which are internal users? And we were like, yes. And so they did it. Yeah, we handle like access controls and everything too. It's not like everyone just gets access to everything. And so like a given team may have had like 100 different models that at some point were created for that team for their Tableau dashboards, right? And what you often end up seeing is like data teams will build dashboards specifically or models specifically for dashboards, right? So then you end up having duplicate metrics that all have their dependencies. And sometimes you don't do the same metric the same way. So now you have two different numbers on two different dashboards that should be the same number. And so that is a problem that if anyone had a silver bullet for, I would pay you a lot of money for it. But yeah. Yeah.
This creates even more potential for this Gen AI to create different values for what should be the same number, right?
Yeah.
Within any analytic department, you want data governance so that one metric is reported once, same number. So you have one senior manager saying, oh, this is the number, and another one saying, no, that's not the number.
Yeah.
Right? How does this type of framework manage that? Because you want to clarify that instead of compounding the problem.
Yeah. So we often tell our customers, like, if you have bad data, adding AI in is just going to like amplify it from the get-go, right? A few of the things that we've had to, when we first started, we were very naive and we were like, hey, I can fix everything. And now what we do, so yeah, we spend a ton of time working with customers to actually get things set up for them. But we really, really push like the unified shared data model approach. If any of you are familiar with like Palantir and how they run like their data strategy or whatever, for better or for worse, it tends to work really well for LLM based analytics. They essentially do, and it's like a buzzword, but it's like an ontological structure where essentially they're trying to take these business entities represented as data, right? Or these objects. It could be a person, a place, an event. And they're essentially trying to create one single gold layer, which is really challenging to do. And so that's why we spend a ton of time working with customers trying to do that. And that I think right now I spend about 80% of my time consulting just on helping companies set up their data foundations. Yeah, I spend a ton of time on it. Now I actually have a lot of things that I've automated that I run like my own scripts for, but they're not like ready for production in the sense that like I can just let them loose like for anyone self-serve onboarding, right? But yeah, the way that we've actually architected the system is to look for those like gold standard metrics first. If it can't find those metrics, Buster sometimes makes assumptions. If it does, we actually have like a confidence score that we associate with things, which is an interesting concept with LLMs. And if the confidence score is not good, we actually route that information back to the data teams. What we want to do is actually route it back into another agent that starts to modify that unified model, right? It's like, hey, user asked about total sales. We don't have total sales, but I think we could have it here, and it makes like a pull request, right, to a DBT model or whatever it looks like. Ultimately, a human has to like check it off, but in my opinion, right now. But yeah, it can totally amplify the problems if you. So what happened with this team that we implemented for, where they had 100 models, two people were asking the exact same question, targeting the same metric, but that metric existed in two different models. And so the LLM, they're totally not deterministic, right? So sometimes it would point to one model, sometimes it would point to the other model, sometimes it would freeze and say, hey, I have access to both and I don't know what to do. And so there was that problem there. And so it introduces like a whole new set of like that's like our biggest problem right now, like, you know, being a little open and vulnerable about our business is, yeah, how do we help companies get ready faster? And that's like been a problem since like day one for self-serve analytics. But we have some ideas that we think we can do it with. And if not, then we'll just have to move up market, and no one wants that. Well, maybe we do. I don't know. Enterprises. I know there's no silver bullet for it. Yeah.
This is logic
Yeah.
into the data, especially when different have different
Exactly.
definitions for
Yeah. Exactly. So yeah, interesting problems. But yeah, I mean, we find a little bit of hope in that we have some, you know, we have some customers that it is working at this point. But yeah, you've like nailed what keeps me up at night. Yeah. Any other questions? It totally ranges. We have one customer that has like 50 terabytes of data that we work with. We have another customer that has like 10 gigs of data. For us, we actually don't have to worry too much about the size of data from the perspective of we don't actually ingest data for our customers. We're just running it on their infrastructure. So whether it's their BigQuery instance, Snowflake instance, we have one customer that we did build like a warehouse for them, like a lake house. It was with Star Rocks and Iceberg. So that was kind of fun, but most of our customers already have like their own solutions. So we run it for them. The one area where we do start to run into interesting problems is people want the LLMs to feel like it's trained on their data, which is impossible because they're not deterministic systems. There's no way the LLM will ever know that, like, you know, in this row of this table, this column, it is a specific value, especially when you're dealing with like terabytes of data or more petabytes or whatever it looks like. And so we have a search index that we built out that's essentially like a tool that the LLM can use where if someone says, show me my Red Bull sales, and it's all lowercase Red Bull, without any context, the LLM might say, select all from products or select sales from products where name equals Red Bull, right? All lowercase. And for the customer I'm thinking of right now, there was no product named all lowercase Red Bull. It was RD underscore BLL underscore 4PK underscore, and then like 50 variations of flavors. So we built a search index that's a semantic search index that essentially allows us to surface like the most relevant values there, and then we allow the LLM to essentially pick out, and those are unique values, by the way, for text values, and we allow the LLM to pick out, should I pattern match, should I exact match? This is like a great place for like that intelligence piece where it can actually try and decide what to do with it. Now, if you have a ton of data, it's like, well, we just built you like a search system that has like, you know, tons of records, and on our side, then we have to make that efficient and stuff like that. But so there are some bottlenecks there, but for the most part, we can kind of handle any size because we're not actually ingesting most of the data. Yeah.